Thanks. Yeah, this will. I promise. I won't show you any kind of these process flows of stage gate or something like that. This will really be a more technical presentation about really batteries, what's going on in batteries at the moment. But nevertheless, I think I will also point your attention to the fact that it's important to understand the market trends. We had a statement today that there's more knowledge out there, and I need to challenge that, as nasty I am. I say there is more information out there, and not necessarily knowledge, because first we need to put the information into the right context to really have the knowledge and how the market is not only changing, but what is the impact to our product, how the customer will use our product in the future. What will be that mean for our products? Will they last longer? Will they last shorter? We don't want to last our products forever, but we also want to make our customers successful. And then it's also the question how we need to change our products to make sure that the customer is still successful with our products, and of course that we are maintaining our profit. That's also not an unimportant thing. And last but not least, that the solution sometimes, not always, but sometimes is not in your standard value chain. So it's outside of your current business. You need to look outside here. Before we start, just a quick overview. Who is Exide Technologies? We are in the energy storage business. 5 years ago, we might have said that we are a lead-acid battery producer. So we have changed also our minds internally, or we are in the process of changing our minds, that we are energy storage company. So we have almost $3 billion turnover, 10,000 employees worldwide, and our biggest markets is the North American part, Americas, North American mainly, and Europe and rest of the world. So 60% of our turnover we are doing in Europe here. And in Europe we have about 5,000 employees, 10 locations where we are producing our products. And 60% of our business is going into the transportation, automotive industry, and 40% of our business is going into our industrial, what we call the GNB. That's a brand name, still existing, GNB Industrial Power Solutions. So we have the standard car batteries, but in our industrial business we also have material handling solutions up to submarine batteries, which are huge batteries, and they are going into the military. Very interesting stuff, but I'm not allowed to talk about that for clear reason. Okay, let's look at the market trends, what we are facing or we are faced over the last years in transportation, and you're all aware about that. It's the CO2 emission reduction. I think everybody heard about that. There are several targets out there. The targets are sometimes postponed or reduced a little bit or increased a little bit if you look at the other side. But there's a clear trend that CO2 emission needs to come down. And what that means to our batteries, our standard batteries, is that they are used today completely in a different way. If you would take a battery technology from your car, which was used 20 years ago, and you would place it today in a modern car, it wouldn't work. So that is a significant change here. And what happened over the years, you need to understand what the change is, how fast it comes. And what we see here in the 2014 number, I hope you can see it from the back, that just only 30% in Europe, not just 30% of the cars in the market produced used standard or standard SLI, we call it, starting lightning ignition battery, and 70% were using already the new technology, what we called the start-stop technology. But it's not only about start-stop, we tend to call that micro-hybrid. And we also see that replacement rate, that's an estimation. Of course, the numbers for the futures are wrong. It's always the question by how much they are wrong. But we also see that here in the future that even in 2020, that just 50% in the aftermarket, in the replacement market, will have a complete different setup. So just 50% will be the standard batteries as we knew it for the time. A similar development is going on in the commercial vehicle. I'm sure you heard about all these Euro norms from Euro 1, 2, 3, and 4. And that also changes the requirements in the commercial vehicle, in the trucks, because they are a very interesting thing. They, with the Euro 4 norm, they had to place the battery in a different location on the truck. So that caused a complete different vibration pattern to the batteries, and the older batteries all failed when they are putting the battery to the different location. So that's pretty interesting how these differences in the market are changing the use and the application of our batteries. And here is a rough overview. As I said, the numbers for the future are completely wrong. The question is by how much. And what we see here emerging over the years is that the standard SLI battery percentage is decreasing significantly. We estimate it will be most likely in 2025 15% or even lower. And there's the big fraction of the so-called micro-hybrid batteries, which is all about the start-stop technology. It's the region energy brake. And there is, of course, an increasing percentage of hybrid electrical vehicles, plug-in electric vehicles, as the Tesla and all these types of cars. But there is also a new technology arising. It's we call it the 48-volt powertrain, which gives some benefits to the customers. And I think to understand what is the impact here is you need to understand how such a micro-hybrid car saves fuel. I think who already knows how micro-hybrid is working? Yeah, that's okay, great. Nevertheless, just a quick explanation. What happens to the battery here is that usually you had the battery in the car and it was there for starting the engine, or you had some auxiliary loads while you're parking and running your phone and listening to the radio, or sometimes even the TV. What the car is a modern car is doing with all the connectivity and all these new customer functions is that it uses more energy. So that will drive the fuel consumption up, because the only energy source in a car you have is the fuel tank. So the more energy you're using with all these modern functions has to come out from the fuel tank. But there is a possibility to use the kinetic energy from the motor brake, transfer it into electrical energy and use that, because that comes for free. When the motor is braking, you have a generator, wonderful. But as in some other areas in the renewable energy, I come to that later, the use of the energy and the production of the energy doesn't occur at the same time. So you need to buffer it, you need to store it somewhere. So you need to have a battery. By the way, we had a battery in our car, but the problem is in the old model, the battery was always on full charge. So how can you put energy in something which is full? So we had to bring down the state of charge of the battery to a certain level to make sure that this energy, which comes for free, is going into the battery and you can use it for your comfort functions. Well, this of course changed completely the use of the battery and also the failure mode of the batteries. And that's something why this development is needed. And the 48-volt development here, it's just a logical consequence, because the more and more power we are using in our cars and we have more and more comfort function, everybody is enjoying that, puts the whole auto industry to the problem that there is a maximum current you can run in a car of about 200 to 300 amps. The higher the power you want to use and your limit with the amps, well, we have technicians in the room. The solution is we need a higher voltage, because it's just, there's no other solution for that. And you can increase the voltage. You can see it here briefly. The higher the power, with a 48 volt system, you can get up to 10 or even 12 kilowatt of power, which in the very high-end car you really need to have to drive all these functions, or even get a little bit more functionality in. Probably also using the electrical motor, which is, the generator for some acceleration assist. So similar like in the Formula 1, the curse system to boost the engine and to get a little bit of more, either a more dynamic drive, or you downsize the engine, the fuel engine, and you have the electrical engine giving you still a good drivability. A further trend, what we are seeing is here that the drive cycle is changing. So there's always norm drive cycles, what you find in the leaflet, that your Volkswagen Golf is using 6 liters per 100 kilometers according to this so-called NEDC. And this one is changing as well, not because of all the Volkswagen issue in the States. This discussion is going on for much longer. And what we can see here is that the stop occasions will increase, the constant drive will increase because we are less and less in a constant drive. We are driving much more dynamic. What will be increased is the acceleration and the deceleration. And especially the deceleration, that offers me the possibility to recoup more kinetic energy from the drive into my battery, which I can use in the acceleration, as I explained, to boost my car and my engine. And also that will change the requirement of our standard battery. Switching gears here, looking at the renewable energy, what's going on there? I think everybody's aware about wind farms, solar panels, and all these kind of stuff. That changes the complete energy distribution. It's a huge challenge for the utilities, especially in the network. It's not just about battery energy storage or building out these wind farms or these solar fields. It's really integrating that into the net. And what's interesting, that's the reason why I brought this number, if you have a look at the external costs, and the external costs are defined, you can find it in the web, are defined on those costs which this technology is causing, which is not on your energy bill. So these are costs for the CO2, for the damage, what this kind of energy production or electricity production has. And even if you talk about here of renewable energy, that the biggest fraction of energy production, electricity production, still comes out of coal. Of course, some countries like Austria, we have wonderful hydropower. That's a complete different system, but a lot comes out of still fossils. And you don't have that on your electricity bill today, but these costs are there. So the whole public is paying for that. And the nice beauty of the renewable energies, it's much lower here. So it's very, very low. But the problem with the renewable energy, it's volatile. So of course you put your windmill where the wind is blowing, and there are some investigations and maps out there where is a windy region, where not. But you usually produce energy also in the solar fields, for example, at this time where you don't really need it. And putting that into the grid is destabilizing the grid significantly. So we see a lot of opportunities in this renewable energy field. And for that, our batteries will also be used completely different. And these are just a couple of applications. What we see in the renewable energy storage, it's we have generally 3 areas. It's an on-grid, it's a smart grid, and it's an off-grid. Off-grid is used in less developed countries over many years, where batteries with a diesel genset was put together, or with a photovoltaic system with solar panels were put together. And what's really challenging is the smart grid, the intelligent grid, and all these kind of stuff. So we have the hybrid and the green deployment. Backup power is also an interesting field, and all this renewable energy management. And just a word to the backup power, because also here we see an interesting trend over the last year. So it's more or less two trends what we are seeing there. Backup power, these are usually big battery systems in a data center or somewhere else, to just being there for an emergency case. And we all heard about these thunderstorms a couple of years ago in North America when New Orleans was shut down completely and they were running out of the battery. So then they decided, well, the battery capacity needs to be bigger. And a second point, what they are now looking in, we want to recharge the battery faster. Because if the battery is there's a blackout, and I can use my battery, and then the power comes back on. So I want to recharge my battery in 1 second or in 5 minutes as fast as possible, because nobody knows when the next blackout comes. And there is also a third thing, which is pretty emerging now, very interesting, that there are big data centers. Companies build the big data centers, they have the backup battery to make sure there is no data loss. And then they say, okay, I have a big battery there. It's a huge energy. Can I sell this in the new regulated or deregulated energy markets? Can I use this battery? While I should sit there and just be fully charged, I can sell that. I can sell that energy on the spot market at a high price, and when the energy is lower, the price of the electricity is lower, I recharge my battery. So they now start to cycle batteries, charge and discharge batteries, which are designed for just sitting there being on a maintenance charge. So that's also very interesting, understanding these trends, and that's the challenge for us here, to really see what's going on the market and transform this information. I always call that information, because information, I need to put that into context, because I just have the information, it doesn't really help a lot. I need to put that into context. What does it mean for the use of my battery? What does it mean? And even if I have the know-how or the knowledge, how to call it, what does it mean? I need to put that into action. Because if I know something, that's nice, it's okay, but as long as I don't put this knowledge into action, then I don't create added value. I can't create any added value, I can't create any improvement. And these are what we have identified in a very brief manner. There are more details behind that, as I can show you here. But there are, in fact, the fast charge issues. You want to really fast charge. That's true also for the transportation, for the hybrid batteries in the car. As I said, the battery is now put on a lower state of charge, because I can't charge a battery which is fully charged. The battery needs to set down on a lower state of charge, which, by the way, the lead-acid system doesn't really like. That's the beauty, or that's not the beauty. The beauty for the R&D people, because now we have work to do. So we need to optimize that. And also what I tried to explain with all these smart grids is also smarter operating strategies. How can I charge my battery? What is the operating strategy? And last but not least, but I will not touch on that, is reducing the product costs. Well, all these requirements, one of the biggest improvements we found is to use carbon materials. And once you go into the carbon materials, there's a huge variety of carbons. Of course, some are considered as the God's best friend, but we are not talking about these. And we already used standard carbon blacks in our battery, but not these nanofibers, aerogels. And we went out and looked into these fields. Of course, these are more the costly fields. We are still looking into nanotubes. That's a pretty interesting material. But we found graphites and activated carbons here. And we found those not really inside our value stream. Usually we were not engaged with these suppliers. But the carbons had a very nice effect here because it improved the surface area. It has a certain capacitance improvement because these carbons are used in supercaps, capacitors. And it also helped us to have more nucleation sites. And also our crystal growth was optimized with that. So we found these carbons helping us, especially in the recharge rate. Don't want to bother you too much with these systems. And also another material out in the carbon field, we found these expanded graphites. And this is interesting because this stuff was used in, or is still used in the lithium-ion battery business as an electrode. And we found out that if we used it in our electrodes as well, it is a different mechanism as we use it. But it also helps us to improve the conductivity, especially by percolation, because once you have a discharged battery, the conductivity goes down. But with adding graphite, as it's shown here in the picture, you can improve the conductivity significantly. Well, and what does that do for the battery performance? We saw here, and that all standard tests what's coming now, and I'm flipping through really fast. In the discharge behavior, you don't really see a lot, but especially in the charging behavior, you have an increase of 30% in this simple high peak power charge test. And if you look into more sophisticated, I promised you it will be a technical paper. If you look at charge acceptance curve, especially at low temperature, because that's always the challenge we have, you see a significant improve over the different state of charges. So it doesn't just help you in a discharge state or in a charge state, it helps you over the whole variety or whole band of battery use. It helps you to improve the recharge rate, and you can see it's stable in the discharge. We don't get a benefit on discharge, but we don't get a drawback, and that's also important. That's just the plot of a different temperature. And if you look in lifetime predictions, and that's also a very interesting, what we call the dynamic charge acceptance test, which is important for the transportation automotive industry, you see that without carbon, you immediately drop down here on very low levels, and you can maintain a much higher charge acceptance over life with this kind of substances. And using that on a lifetime test, you can see that you can increase the cycle number by a factor of 4. And the same happens here if you look into a renewable energy gel, a deep cycle product. It's called the A500 gel product, which is mainly used in renewable energy applications, energy storage for solar panels. You also can here increase the lifetime or the cycle life of the battery significantly. That doesn't mean that the battery then lasts 4 times longer, but you can use it 4 times intensively. Well, what can we conclude here? That, of course, energy storage will be more important. That's absolutely not a question. We will see much higher diversity. That's also clear for us. And we have now, I think that with the carbon additives, we have really a good source here to further improve the lead acid technology. Of course, we still need to understand all the side reactions. Not every carbon is acting the same way. And last but not least, we will have also the fight, or not really the fight against modern technologies as lithium-ion. We also need to understand that in some applications, advanced technologies like lithium-ion will be the better solution, but we think that we have a small activity also in lithium-ion, so we have experience always there, also there. And last but not least, the final comment here, with because we heard a lot about sustainability and all these kind of stuff. I think not a lot of people know that the lead acid battery is the most recycled product all over the world. It's 99+%. So we don't have really this issue of what is about sustainability, what is about the closed loop. 99% of the battery is really recycled. So when I say recycled, it's not downcycled. The battery, the junk battery will become, after the recycling process, it will become a battery as well. So you can really use the materials as a closed loop recycling, and that is one of our really big advantages in the future, and that makes this product pretty green. That's it so far, and happy to take any questions.